Students, welcome to the first live session of the course Sustainable Power Generation Systems. So in this session, I would like to mention what content. Welcome to the first live session of the course of Sustainable Power Generation Systems. So the kind of modules we have covered so far is module 1, Introduction to Power Generation Methodology. In module 2, Solar Thermal Power Generation Systems. In module 3, Solar PV Power Generation Systems were discussed. And in module 4, wind power generation systems are elaborated. So primarily in first module, we have introduced all kind of renewable energy generation systems and its merits and demerits, and what renewable energy systems are most prominent in region-specific solutions. And also, we have discussed the global energy mix and Indian energy mix, from where we are trying to understand the requirement of renewable energy. And also, we have discussed about emission characteristics and what are the countries emitting more energy. That means they are producing more energy and emitting more carbon dioxide to the Earth atmosphere, and how we can minimize those carbon dioxide emission to the Earth atmosphere. These strategies were elaborated. In module 2, all kind of solar power generation systems were discussed. Like we have different solar power generating systems like parabolic trough central power receiver systems. In parabolic trough systems, what happens? We have a concentrator and a absorber. So solar radiation falls on the concentrator and then it reflects to the absorber. And absorber is nothing but a annulus tube. At the core, heat transfer fluid flows from one end and collects in another end. And of course, the tube is a transparent tube where both normal radiation and diffuse radiation falls over the absorber tube. And the reflector uses reflected beam radiations for heating the heat transfer fluid. So finally, that heat transfer fluid exchanges heat with water and then it produces steam. So once we generate steam, then we can route through a turbine where we can generate electricity by coupling a alternator. And of course, we need a condenser to condense the steam to water, and then pump is used to pump the water to the original circuit again, and it will work in a closed loop. Same Rankine cycle principle is applied for power tower concept, but there solar harvesting is somewhat different. So what you will have, a lot of heliostats where solar radiation falls and reflects to the top of the tower, which is nothing but the absorber. And then some material is pumped to that absorber for heat exchange, and these are stored as a heat transfer media, and when electricity is required, that is transferred to water and then produce steam, then electricity in a Rankine cycle. So these all kind of power plants for thermal energy generations, and we have other fundamentals already discussed in the lectures in module 2. In module 3, solar PV power generation systems were discussed, starting with very fundamental components. We have formulated the mechanism of understanding of power generation principles through solar PV systems. First, we're learning what is PV cells, then what is PV modules, then arrays. How these components can be applied in respective applications. Say, for example, to energize the PV cells, what is used in calculators, what kind of principle is used, then what kind of cells are used for, say, power generation applications. It may be standalone system or maybe power generation systems, grid connected systems, and how these two standalone and grid connected systems are designed. So this has been elaborated extensively in this module. And in module 4, solar power generation systems are discussed, which includes, like, first start with the energy scenarios for wind energy harvesting in India and global, and then what is the potential of wind energy in both global and Indian context, and then what are the different wind machines available for energy harvesting, what is drag type wind machine, what is lift type wind machines, and then what are the performance parameters of a wind machines. Like we have coefficient of power, how we can define coefficient of power, how we can extract energy from a wind machines, what is the potential of wind with respect to velocity and all, and then what maximum power can be harvested by using a wind machines, and then numerical calculations. If, say, for example, if we know, say, diameter of a wind machine and this rotational speed, then we can find out tip speed ratio. Of course, we need to know the wind velocity. It is something like omega r, that is tip speed at the tip, that is speed at the tip, to the wind speed, that is omega r by u infinity. So if you know rotational speed and then radius of the wind machine and then wind velocity, then you can find out this lambda. And this lambda also depends on different factors, like how precisely we can design the wind profile. That means blade profile. Okay, and as you know, blade profile has to be very smooth, and we must have some knowledge about its chord, its camber line, okay, and what is length. So once we know cambered line, that is C, and its length, then it gives you an area. That means L into C is nothing but area. So if we know this area, and if we know the swept area, that is pi d square by 4, then we can find out what is the solidity. Solidity is a factor which is required to be designed or understood to know like how much solid is there in the wind turbines. If we cover the entire part of the wind turbine by solid sinks, that means no wind is moving. Wind is coming and striking, it's like a solid plate. So how much solid they have removed, and maybe we kept 3 blades. So if we know the area of these 3 blades and its swept area pi d square by 4, then from that we can find out what is the solidity. And then next, what we are interested about, power, coefficient of power calculations. Okay, so finally we are into the process of design of wind turbines. So these many components are covered in these 4 modules. So if you have any queries, then you can ask me. Of course, most of the doubt has been cleared in the discussion forum. So still, if you want to clarify some of the doubts, then you can ask me. And also I suggest you to put your questions in the discussion forum. Then we can provide the reply very comprehensively. So I'd like to thank you for registering in this course. And this course really gives a foundation to know about all kind of renewable energy systems. Please ask some questions if you have. I think since there is no participants and no questions, we can conclude here. And if you have any queries, you can ask. Otherwise, no, I am concluding in 5 minutes. And if you have any doubts, you can raise in a discussion forum. Okay, then I am concluding here. Thank you very much.